Hello everyone. This is Rajoshi, and today we are going to solve a new problem which is present in the DSA platform given by Pritish Chaudhary sir, which is valid parenthesis. It's a very, very popular problem on LeetCode, and you can find that this particular problem is asked by many companies. So let's discuss a little bit what the problem wants. So actually, we are given a string of brackets containing characters like this, and this. That means a pair of first, second, and third brackets. Now we need to determine whether it is valid or not. Every opening bracket must be closed by the matching bracket. Then it is valid of the same type. Else, the bracket must be closed in the correct order. And this particular question is asked by this companies. So how we are going to solve this problem? So if the string of the brackets looks like this, we can see that for this pair, this is a matching pair. Then if we remove this, then this and this are matching pair. If we remove this, then this and this is a matching pair. So you can say that it's a valid parenthesis. So how we are going to solve this problem? Uh, is so first of all, how what our algorithm tries to say us that we are given a string. We need to repeat this. That means we need to traverse over the string. Then we need to find an adjacent pair of first bracket pair or second bracket pair or the third bracket. If we found any pair, then we need to delete the pair, else we need to break it. And if the conditions are not satisfied, then we need to return the S is empty. That means the string is empty. So how we are going to do that? So first of all, our intuition tells us that is every bracket closed by the right partner in the right partner in the right order. The first idea, an adjacent pair like this, or this is definitely valid. Uh, Delete it and ask the same question about the remains. Okay, so this is a very simple line. We do not need to uh, think more behind the logic. Okay, if I start the animation, it says that we are trying to find the perfect pair. So here, our pair got matched. So in the round one of scanning, we are, for the remaining characters, we got the uh, pair of the second parenthesis, as the positions of 2 and 3 are adjacent matched pairs, right? Now, what we need to do, we need to, in the previous step, we need to delete it. So our new string will be the opening bracket of first bracket, then the opening bracket of third bracket, then the closed bracket of third bracket, then the closed bracket of first bracket. Right? Again, we found a pair, the pair of third brackets. Then we can just in the next phase we just need to delete it again. So just only uh, two string characters are present: the opening first bracket and the opening closed bracket, the closed first bracket. Then again we found a pair. It is a matching pair. So we are repeating it, right? We deleted it, and at last we are uh, returning the string as empty. So if we are trying to practice it, it is a very simple logic. That's why I'm copy pasting the logic. copy pasting the pseudocode, and if we evaluate it, it will give us that we have successfully done the entire thing with a time complexity of big O of n square. But why it's big O of n square? Because we are using a nested loop. So first of all, first one is to find the opening pair, and the second one is to find the closing pair. So in the worst case scenario, we need to traverse the entire array for 2 times within a loop under the loop. That's why the time complexity is big O of n squared. Now we are going to solve this same problem in big O of n time complexity. So let's do it. Yes, now we are going to use a stack. So let me tell you what the problem of how the algorithm is designed to solve this particular problem. So first of all, here we are going to use an extra data structure, which is a stack. We know that stack is a LIFO, last in first out data structure. And our algorithm says that we are given a string of brackets. Then we need to initialize a stack. Then we will iterate over the string and we will grab each and every characters. Okay. If the character opens, that means if the character is an opening bracket, then we are just going to push the character into the stack. Else, then we are going to check for another condition, that if the stack is empty or the top mismatches, then we are going to return false. Else, in the previous step, we are deleting it. Here we are going to pop it. And if the entire if blocks doesn't satisfy its criteria, then we are going to return the stack as empty. So let me start the animation to visualize how it's working. So first of all, we have the most recently opened closes first, right? That's why we are using LIFO data structure, which is a stack. So keep open brackets on a stack. A close is valid only if the match is with the top, right? Now, if we start the animation, here our stack is empty. We have initialized an empty stack. I think I skipped it. Right? Yes, in the first iteration, where I equals to 0, we have encountered an opening bracket. Right? So this particular thing is an opening bracket. So that's why we are going to push it into the stack. So our stack contains this. Then in the where the I equals to 0, that means in the second iteration, we got this. It's also opening bracket. This criteria got satisfied. That's why we are going to push it again. We are going to do the same for this second opening bracket. Yes, now the condition changes. So for the fourth iteration, that means I equals to 3, we are not going to encounter any opening bracket. We have all the closing brackets. So the else blocks runs, and in the else block, we have another nested conditional statements. So here, what we are checking that if the stack is empty, or so our stack is empty. No, our stack is not empty. And the top mismatches. So our top is mismatching with this pair. So we have the closed second bracket in our iteration, and we have the closed opening second bracket in our iteration. That perfectly matches a pair. So we are not returning a false. So what we need to do, we just need to pop it up. Right. We just need to pop it up. So from our stack, the opening second bracket is gone, and as we are inside a loop, so we need to follow the same thing unless the stack is getting empty, right? So if I start the animation again, so it perfectly matches a pair. We are going to pop it. Yes, we are popping it. Then again, it is also making a pair. So we are going to pop it again. Now our stack is empty. So we are returning our stack is empty. So this is how we are going to solve this particular problem. So now let me write the pseudocode. So we are given a string S. Then we need to initialize a stack. So we have initialized a stack successfully. Now we need to traverse over the string. So for each character of the string, we are taking it and we are checking for a condition that if the string, if the character opens, if it is the opening character, then we are just pushing into the stack. So push ch, right? Else what we are going to do, we have another nested conditions that if our stack is empty or our character mismatches the st dot top, that means the topmost element of the stack. If this condition satisfies, then we are going to return false, right? Else we are going to pop from the stack. And lastly, we are returning stack is empty, right? Let me copy the code once. Yes, and let me evaluate it with the help of AI. Okay, we have made some syntactical mistake here. So let me see what are the mistakes. So the top mismatches and the stack is empty. So basic mistakes, it shouldn't be made any test cases, right? Top, so stack is empty. I think it should work right now. It should work right now. Okay. If ch opens, okay, so let me just copy and paste it because our logic is pretty much rock solid as we can understand that what is going on algorithmically. So let me just copy and paste it because you can see that my written pseudocode and the pasted pseudocode is pretty much same. I am copy pasting it, but why it is giving me this uh, error? Okay, so let's directly jump into the lead code. So this is the valid parenthesis problem. And what we have done here is we have initialized a stack of character, right? To track the opening and the closing brackets. Now, what we are doing that we are just traversing over the string. So for us, this is a string. Now we are picking up each and every character. So s that caret I. Then we are checking for one condition that if our stack is empty, if our stack is not empty, then we are just picking the last element and we are checking for a paired thing. That means we need to check the brackets are uh, getting configured with the pairs, right? So how we are going to check it? So we have a Boolean field. So we are checking that the last is this and the current is this. Then it's a pair. If the last is this and the current is this, then it's a pair. If the last is this and the current is this, then it's a pair. And if this is a pair, then we are just popping it and our loop goes into the continue mode. Else, we are just pushing it into the stack. And at the last, we are returning the stack dot is empty. It's returns some boolean. Now let me run it. Yes, it runs successfully. Now let me submit it. Yes, we have solved the problem successfully. So I think we have made a syntactical mistake here because I am copying and pasting the thing, but still it giving me that I have made a syntactical mistake for writing the right. So we have successfully solved the problem. Here our time complexity is big of n because we are traversing the entire string just once. That's why it's a big O of n. And we are using big O of n space complexity. Why? Because we are using an extra data structure, which is a stack. And in the worst case, where we have all the brackets are opening brackets, then we need to push it onto the stack with the size of the string. Right. So that's why our worst case time complexity is big O of n. So this is how we solve this problem. Let's catch you up in the next video. Thank you for watching.